Hello students, in the chapter Quadrilaterals, let's solve exercise 7.1 in this video. First problem, the angles of quadrilateral are in the ratio 3:5:9:13. Find all the angles of the quadrilateral. So, its ratio is given. Okay. So, how we can take? We can take the sum of the angles, so interior angles of quadrilateral is equal to 360 degree, that we know. Okay, so ratio is given, so we can take it in the form of 3x, 5x, 9x and 13x. We don't know what is x now, so we are taking the ratios by 3x, 5x, 9x and 13x. So all together if you add, you will get 360 degree. So after adding, I am getting 30x is equal to 360. So what is x? Bring the x to the RHS in division. So you will get 360 divided by 30, that is equal to 12 degree. So x is 12. So each angle, so 3x means how much? 3 into 12, that is 36 degree. 5 into x, so 5 into 12 is 60 degree. 9x, 9 into 12 is 108 degree. Then 13 into x, 13 into 12 is 156 degree. So this is how we found all the angles. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So what is given? It's given the diagonals of parallelogram are equal. Diagonals are equal, that is given. So we should show that it is a rectangle. Okay. So given is AC equal to BD, that is diagonals are equal. So we should show that the diagonals are equal means it is a rectangle we should show now. To show ABCD is a rectangle, we have to prove that one of its interior angle is right angled. Okay, in a parallelogram, suppose the normal parallelogram means it's not necessary to have any angle as 90 degree. But if it is a rectangle, it is a must. It should have a 90 degree. Okay, between the sides, the angle should be 90 degree. So that's what we are going to prove, that it is a rectangle. Proof. In triangle ABC and BAD, BC equal to BA, that is common. Okay, BC and BA, that is common for these two triangles. Sorry children, typing mistake. It is BA equal to BA, because for these two triangles BA is common. Okay, so it's BA equal to BA. Then BC equal to AD. This BC is equal to AD because it's a parallelogram where the opposite sides are equal. Okay, then AC equal to BD. That also given in question, that the diagonals are of equal length. So, triangle ABC is congruent to triangle BAD by SSS congruency rule. Okay, that means these two triangles are congruent. So, if it is a congruent, angle A equal to angle B. Okay, these two triangles are congruent. So, these two are the corresponding angles of congruent triangle, no? So, these two are equal. Okay. Also, angle A plus angle B equal to 180 degree. Sum of the angles of the on the same side of the transversal. Okay. So, these two are parallel. Okay. So, in a parallelogram, the opposite sides are parallel. So, if it is parallel, then this line is the transversal and the sum of the angles on the same side of the transversal is equal to 180 degree. Okay, therefore, these two angles, if you add, you will get 180 degree. So, here only we said it is equal. So, replace angle B with angle A. Angle A plus angle A you will get. So, 2 times if you add, it is 2 angle A. Okay. So, 2 angle A equal to 180 degree. So, take the 2 to the RHS in division. So, you will get 180 divided by 2, that is 90 degree. So angle A is 90 degree means angle B also 90 degree, because we only said it is angle A equal to angle B. Both are equal to 90 degree. Okay, so this is possible only when ABCD is a rectangle. Okay, so hence it is proved that the given parallelogram, it's a rectangle. The next problem. Show that if the diagonals of a quadrilateral bisect each other at right angle, then it is a rhombus. So diagonals of the quadrilateral is bisecting at right angle. Then we should show that it is a rhombus. So let ABCD be a quadrilateral whose diagonals bisect each other at right angle. Okay, so this is the diagram. So you have four sides and diagonals are intersecting at O, and you have 90 degree at point O. OA equal to OC, OB equal to OD. Okay, so bisect each other means it is equal. It is into two equal halves. So that's why we are writing like that. And angle also. So the angle, these AOB, AOD, similarly DOC and COB, all these angles are equal to 90 degree. So we have to show that it is a rhombus. So how to do that? We have to prove that ABCD is a parallelogram and AB equal to BC equal to CD equal to AD. Okay, so that means it's a parallelogram with all four sides equal. Then it is called a rhombus. So that's what we have to prove now. So prove in triangle AOB and triangle COB. So OA equal to OC, that is given. Okay. Then angle AOB equal to COB. Opposite sides of the parallelogram are equal. Whether it is a rhombus or normal parallelogram, you have opposite sides are equal. That's why we say that it's equal. Then OB equal to OB. That's common. So for these two triangles, OB is common. So that is also equal. So therefore, these two triangles are congruent by SAS congruence. Okay. Thus, we can say that AB is equal to BC. Why? Because corresponding parts of congruent triangle. So AB is equal to BC. Okay, so that we are saying that these two sides are equal. Similarly, we can prove BC equal to CD, CD is equal to AD, and AD is equal to AB. So by that we can prove that AB equal to BC equal to CD equal to AD. So how we proved with two triangles that these two adjacent sides are equal. Similarly, you can say these four sides are equal. So by that we can prove that opposite sides of quadrilaterals are equal. Hence, ABCD is a parallelogram. ABCD is a rhombus as it is a parallelogram whose diagonals intersect at right angle. So we can say by this. So actually, you can say that all four sides are equal. So by that we are saying that it's a rhombus. Hence it is proved. So actually, so I corrected here, children. So it's diagonals intersect at right angle and all four sides are equal. Because of that, it's a rhombus. Okay, so now this is correct. The next one, show that the diagonals of a square are equal and bisect each other at right angle. So if it is a diagonals of square means that it will bisect each other at right angle and they are of equal length. We have to show that. Let ABCD be a square and its diagonals AC and BD intersect each other at O. To prove AC equal to BD and AO equal to OC, then angle AOB equal to 90 degree. So all these things we should prove now. So proof, we are taking the triangle ABC. Okay, ABC triangle we are taking, and BAD. This triangle we are taking. Okay, ABC and BAD. These two triangles we are taking. And if you see here, BA is common. Okay, both are having this side. So BA is common for both triangles. And angle ABC is equal to BAD equal to 90 degree. Okay, so since it is a square, you have 90 degree. Then AC equal to AD. Okay, that's a diagonal. Okay, so AC equal to okay, in triangle ABC and BAD, we have BA equal to BA. Okay, so for both the triangles, this BA is common. Okay, then angle ABC equal to angle BAD. Okay, angle ABC, this angle, and BAD, this angle are 90 degree. Okay, why? Because it's a square where you have the angle as 90 degree. And BC equal to AD. BC and AD are equal. Why? Because opposite sides of square are equal. Okay, so by SAS congruency, you can say that these two triangles are congruent. So by that we can say AC equal to BD. That is, corresponding parts of congruent triangle are equal. So what is AC and BD? They are the diagonals which are equal. Then now we are going to take AOB and COD. These two triangles we are going to take. These two triangles. Okay. So in that BAO, this angle and this angle, that is DCO. Okay, so these two angles are equal. Why? Because they are the alternate interior angles, because these two lines are parallel. Okay, so these two lines are parallel means then this is the transversal passing through it. So alternate interior angles will be equal. Then these two, AOB and COD, these two angles are equal. Why? Because vertically opposite angles. So one more side, that is AB. AB is equal to CD, because in a square opposite sides are equal. So by that we can say that that two sides are equal. So these two triangles are congruent by AAS congruency. So by that we can say that AO is equal to CO. Why? Because corresponding parts of congruent triangle. So these two lines are equal. So that means diagonal bisect each other. So the diagonal will be bisect into two equal halves. Now coming to the next one. So AOB, this triangle, and COB, these two triangles we are going to take now. In that OB equal to OB. Why? Because it is common. For these two triangles, OB is common. Then AO equal to OC. Just now we proved no diagonals are bisected. So these two sides are equal. Then AB equal to CB. These two sides are equal. Why? Because sides of the square are equal. All sides of squares are equal. So by SSS congruency, you can say that these two triangles are congruent. So if it is congruent, we can say that AOB, angle AOB and COB are equal. Why? Because corresponding parts of congruent triangle. But we don't know how much length, angle it is. So for that we are taking these two as linear pair, and linear pair addition is equal to 180 degree. Just now we said these two are equal. So it has to be 90 degree. 90 degree plus 90 degree only will give you 180 degree. Okay, so everything we proved now. Diagonals bisect each other at right angles. First we said diagonals are equal, then they bisect each other, then they bisect at right angle. So everything is proved now. So I'll wind up this video here. I'll continue in my next video. Thank you, children.